In 7-8, we're going to deal with two topics. One is the volume of a three-dimensional figure and the surface area of a three-dimensional figure. So the volume is the number of cubes that fit in a three-dimensional figure. If we looked at a rectangular solid, I'm going to build one here so we can look at it. Get something so you can actually see this. We're going to build one. The first one we're going to build is going to be sort of flat. And that's like a box, as you can see. And how many cubes are there in that box? There's 6, right? So if we add another layer, now we have a box that's a little bit deeper. And we had 6 cubes on the bottom layer and another 6 cubes on this second layer. So now we have 2 times 3, which would be 6, times 2, which would be 12. We could even add another layer to that. Now we have a nice deep box. And we have another 6. So we have 6 on the bottom layer, 6 on the middle layer, and 6 on the top layer. So we have 2 times 3, which is 6, times 3 layers, which would be 18. So that's actually what we're going to do on our formula. We're going to find out how many in the bottom layer. So the volume would equal length times width. And then we're going to multiply it by the number of layers that we have. So the volume is equal to the length times the width times the height. Now I'm going back to my little cheat sheet. I think I'm just going to start on the back. I probably wouldn't do this, except I think it'll be easier for you to follow. So I'm going to make a section for volume. And this is the number of cubes in a three-dimensional figure. And so our units are now not going to be squares. They're going to be cubic units, or we can write it with an exponent of 3, cubic units, either way, or you could just write CU feet or inches or whatever it happened to be. Okay, so let's get this one on there. We're gonna draw a rectangular solid. So I'm pretty good at drawing these. And we have the length, the width, and the height. So the volume is equal to the length times the width times the height. And it doesn't matter which is the length, which is the width, which is the height. It kind of depends on which way the box is sitting or the rectangular solid is sitting. So we know that 2 times 3 is 6 and 6 times 3 is 6, and the same thing happens if you have 3 factors. So it doesn't matter which dimension, which number you put with each, you're going to multiply the 3 dimensions of the rectangular solid. The next one is a cube, and the only difference between a cube and any rectangular solid is that all the dimensions are the same. Every face is a square. So the bottom layer, we're going to have a square. On the next level, we're going to have a square, and so forth. So what we're going to do is we're just going to take the volume side times side times side, or if you want, you can use this formula up there. All the numbers will be the same, but it will be the same, this times this times this. Or the shortcut way of writing it would just be the side cubed. So let's write our formulas down here. That's the easiest one. What that means is this, or we can use this formula, length times the width times the height. Next, we're going to look at a cylinder, which is like a can. And so when we look at the layers in the can, we see that each one is circular. So to find out how many squares or cubes in one layer, we're going to do pi r squared. That would be the number of squares in the bottom layer. And then we'll multiply it by the number of layers that we have, which we call the height. So we have the height, and then we have this circular area that we're layering on top of each other. And we are going to use the radius, which is from the center to the outside. Okay, so this is the radius, and then we have the height. So the volume is equal to pi r squared, that's one layer, times the height, which is the number of layers that we have. The last figure that we're going to include is a sphere, which is a ball, and it has kind of a funky little formula. The volume is equal to 4/3 times pi r cubed, and we want to be sure this is cubed. And I'm not sure how this was developed, but take my word for it. This is the formula that we're going to use. So we'll draw a picture. This will be a cylinder. I didn't write it on there. And then we have the sphere, which is like a ball. Okay? And we'll make a round circle, and then we'll kind of show that it's three-dimensional by doing that. And what we're interested in is the radius. So the volume of a sphere would be 4/3 pi r cubed. And we want to be sure that we're using cubed, because sometimes, we just use r, sometimes we use r squared. In this case, we use r cubed times itself 3 times. Now, if you have run off the geometry practice, this is the second page of it. We're finding volume. We're going to write the formula, show the substitution, and label our answer. And we know that our answer is going to be labeled cubic units, and that's going to be worth 0.5 point. So you want to be sure that you have that in your little brain. These will be on the test in separate sections. So these are things that you can do. You can go through each section and be sure that the area is square units, the volume is cubic units. So here we have a rectangular solid. And here's the 3 dimensions, and we're going to look at our little cheat sheet. And our formula is the length times the width times the height. So we'll write that formula. One of these dimensions is the length, one is the width, and one is the height. And it doesn't matter, again, which is which. So if we're going to substitute, I've just labeled this 6 is the length, 1.5 is the height of the width, and 2 is the height. So when we multiply those together using our calculator, I'm going to put 6 times 2 is 12. I'm not very good at using my calculator. So 12 times 1.5, and I get the volume to be 18. This is measured in centimeters, and since we're finding volume, it's going to be cubic centimeters. This next one is a cylinder. So we'll look at our cheat sheet and get our formula for that. Pi r squared times the height. Pi r squared times the height. So if we set this can up, this would be the height, and this is the circular part of the can, so this is going to be the radius. And it goes from the center out to the outside. So the volume is equal to 3.14 times 3 squared, the radius squared, times the height, which is 15. So I know that 3 squared is 9. So 9 times 15 times 3.14. And I'm getting 423 9/10. This is measured in feet. We're finding volume, so it's cubic feet. The last one is a sphere. So we'll look on our cheat sheet. And in the volume section, I'm looking for sphere, and the volume is equal to 4/3 pi r cubed. So here's r, that's the radius. So the volume is equal to 4/3 times pi, and we're using 3.14. The radius is 5, and we're going to cube that. So we'll do the cubing and then the multiplication and division left to right. So 5 cubed, 5 times 5 times 5 is 125. And now we're going to multiply by 4/3, which means you can multiply by 4 and divide by 3. And then we're going to multiply by 3.14. So what I'm getting is 523 and this 3 repeating. That 3 repeating. And this is measured in yards, so this is cubic yards. You know, 4 divided by 3 will give you 1.3 with the 3 repeating, and we wouldn't round that. And we can multiply that by 3.14 and take that times 125. And I'm getting a different answer, so let's use this answer because I think this one might be right. 566, and then the 6 repeats, cubic yards. So 4 divided by 3 times 3.14 times 125. Now I'm getting the last answer. I don't know. I think maybe, you know, how I do with this. So 4 divided by 3 times 3.14 times 125. I think this is the right answer. So 4 divided by 3, you're going to do the division and multiplication left to right. I think that was the problem when I did that first. Well, no, that's what I got the first time. I don't know. 4 divided by 3 times 3.14 times 5 cubed. So we'll do the exponent first, which is 125. Then we multiply 4 divided by 3 times 3.14 times 125. And that's what we should get. Perfect. So we've done volume, and now we're going to look at surface area. Now, what I want to show you on surface area is what that really means. The area of the surface, the material necessary to cover the shape or to make the shape. So, let me get a piece of green paper. I think you'll be able to see it better on that. So we're going to look at the cube first. So here's a cube. It's a square on each side. And this is what it looks like. This is what we call the net. This is what the net looks like if we wanted to make this, out of a piece of cardboard. You see, there's our cube, and this is what it would look like. That's what the covering would be, or the paper that we would make it out of. So when we go back to our notes, we have 4 of these in a row. 2, 3, 4. And then we have 1 on the top and 1 on the bottom. These, the ones that I made, happen to come across here, but it doesn't matter. They'll just fold over, and this will be the top, and this will be the top, and this will be the bottom. So what we have are 6 squares, and each square is side times a side, side times a side. That'd be that square, and we have 6 of them. 1, 2, 3, 4, 5, 6. So the surface area would be, this is our formula. So I'm now going to start another section. This is going to be surface area. So if I'm asked on the test for the surface area of something, these are the formulas that I'm going to use. So we start with a cube. We know what that looks like when it's all put together. Looks like that. And if we look at it like this, I think this is the way your notes are. It has 6 squares. So the surface area would be 6 times s squared, because each of these are s by s. The next one is the most complicated formula that we have. It has to do with the surface area of a rectangular solid. This is a rectangular solid. You know, it has 3 dimensions: length, width, and height. And if we unfold this, it looks like this. So we have 6 rectangles, but they're different sizes. We have 2 that are the back and the front. They're the same, the back and the front. And then we have 2 that are the top and the bottom. And then we have these 2 ends. So we're just finding the area of the paper, the surface area. So we have 2 that are the length times the height, 2 that are the length times the width, and 2 that are the height times the width. So you want to be sure what order you have these 3 add-ins in, doesn't matter. But you need to have 2 of these rectangles, 2 of these rectangles, and 2 of these rectangles. So let's get that on our notes here. Drawing a 3D picture. We have length, width, and height. And the surface area would be 2 of those, plus 2 of those, plus 2 of those. And they just give them in this order. Length times the height. That way you won't miss anything. Length times the width. And height times the width. We have 2 more to look at. We have the cylinder. You know what that looks like. The one that I have made here is kind of more like a tuna can than anything. And if we undo this, we end up with the top and the bottom. And we have this part that wraps around. I like to refer to this rectangle as the label, because it wraps around to be the sides of the can. So, pi r squared would be the area of the circle, and we've got a top and we've got a bottom. So we've got 2 of those. And then this rectangle here, it's as tall as the can. That's where the H comes from. And then this has to fit around the circle. And 2 pi r would be the length, the distance around the circle. So we have 2 pi r times h. This from here to here is 2 pi r. This would be the height of the can. So this is the height of the can. And then we need to know the radius of the top or the bottom. I'm going to put that on my sheet. I'm going to make me a little can here. This is a rectangular solid. I didn't write that on here. And this will be a cylinder. And what we have the top and the bottom. And we need to know the radius, and we need to know how tall the can is. So, the surface area is equal to 2 pi r squared. That's the top and the bottom. The 2 is for the other one. So we have, this is the top, this is the bottom, and we have 2 of them. Plus, and then we have 2 pi r times the height. 2 pi r, that's the distance around, that's where the label has to wrap around, times the height. And the last thing we're going to find out is how much it takes to cover a ball. Now this, as you know, if you've ever tried to do this, you've got weird shaped things. So they have used all kinds of mathematics to come up with this formula. 4 pi r squared. So I don't have much room here. I'm going to kind of do it down here. I've got a sphere. And we need to know the radius. And the surface area would be 4 pi r squared. So now we have all these formulas on our cheat sheet, and you know, there's a lot of room on here, so you could move them up and do whatever you want with them. We've got a practice sheet. Here's our practice sheet. We're finding the surface area, so we're going to use the surface area formula for each of these. And we can go to our cheat sheet, the surface area. To find, this is a rectangular solid. So here's our rectangular solid. Here's the formula. 2 length times the height plus 2 length times the width plus 2. I wish I had a little more room on this paper. I'm just going to write that down here. Plus 2 height times the width. Okay, now I'm going to substitute. I'm going to label these on my drawing because sometimes it's hard to remember which is which. It doesn't matter which is which as long as you substitute them in various places. So I'm going to call this the length, this the width, and this is the height. So 2 times the length, 6, times the height, which is 2, plus 2 times the length, which is 6, times the width, which is 1.5, plus 2 times the height, which is 2, times the width, which is 1.5. Okay, so I'm going to find this product, this product, this product, and then I'm going to add them together. So 2 times 6 is 12, times 2 would be 24, plus 2 times 6 is 12, times 1.5. Which is 18, plus 2 times 2 times 1.5. So this would be 4 times 1.5, which is 6. So now I'm going to add these 3 numbers together. I have 24 plus 18, which would be 42, plus 6, I think is 48. And now remember, these are flat. These are flat. So we're talking squares. We're talking about square units. So this is measured in centimeters. So these are little squares that are centimeters squared. Okay, next let's do the cylinder. And here's our formula. 2 pi r squared plus 2 pi r h. So this is the height of the cylinder, and this would be the radius. So let's substitute in here. 2 times 3.14 times 3 squared plus 2 times 3.14 times 3 times the height would be 15. So I'm going to find this, and then I'll add them together. So 3 squared would be 9 times 2 would be 18. So 18 times 3.14. 56 and 52 hundredths plus 2 times 3 would be 6. 6 times 15 would be 90 times pi. $282 and 6/10. Okay, so I'm going to add those together. That plus 56 and 52 hundredths. I'm getting 339 and 12 hundredths. This is measured in feet, so we're having square feet. Okay, the last one is the sphere. This is a cylinder. And our surface area is equal to 4 pi r squared. So this is the radius. It goes from the center out. So the surface area would be 4 times 3.14 times 5 squared. So I'm thinking 5 squared is 25 times 4 would be 100. And we're taking 100 times 3 and 1400ths, which would be 314 square yards. Surface area is in yards, volume is in cubes, area is in squares. So I'm going to make me on, I've just got this nice area up here. So area is square units. Volume is cubic units. And surface area is, again, square units. So this is important, and you can go back through each section. The test will be in each section. You'll have some area, you'll have some volume, you'll have some surface area. You can go back and double check and be sure you have the area answers labeled square units, the volume in cubic units, and the surface area again in square units, because we're talking about flatbed